first we want to start by looking at what would a developer experience as they go through an application deployment process with OpsMx Delivery Shield as part of their environment. And so what we're actually going to show you in the demo sequence that Bob is going to go through in a minute is really a two-part demonstration. First, we're going to show you what happens if I try and release an application, a version of application that has a critical vulnerability in it. So you'll see developer submitting a PR, you'll see the application is getting blocked by OpsMx because it's out of compliance, and then you'll see how you can use OpsMx to go in and look and understand what happened within that environment, right? Then we'll repeat that process after the release has been corrected, after the application has been corrected, resubmitting the request, the release going through smoothly and uneventfully, and then seeing that information as well in OpsMx. So again, really trying to show you how this will work from a developer standpoint. Now, what we're showing in this demo is something that we call secure GitOps. We see more and more organizations moving to a GitOps deployment model as they for their future applications and as they evolve their CI/CD practice. And so, a standard GitOps model is designed to just move very quickly and get releases out very quickly. So the developer will submit their PR, Jenkins will trigger a build gets added the artifact, Argo or whatever GitOps tool you're using, then would be monitoring, watching for new artifacts, and then deploy that to Kubernetes. Right? In this standard GitOps process, there's no notion of a policy check, a security check, a review check, other than the approval of the PR itself at the start of the process. In the demo, you're going to see what we call secure GitOps, where we're actually adding kind of another kind of parallel workflow that happens in the background while the GitOps process is going. And so when that PR gets submitted and approved and triggers the build in Jenkins, right, and creates and puts the build in the artifact store just as it normally would, our OpsMx product is going to detect that build, and we're going to use that to trigger a security scan. In the picture here, we're using Trivy to do that security scan. And then we're going to evaluate the results of that security scan, and from that make a go, no-go decision. If we find a policy violation that is severe, we're going to use admission control as part of Kubernetes to block that artifact from being deployed, and that'll then be reflected back in Argo as a deployment block because it's out of compliance. Right. So if the security scans all look good and there are no issues, from the developer standpoint, the release happens just like it normally would. If there is an issue found in the release, then the developer receives feedback that it's been stopped, right? So this is the idea of guardrails. We want to implement security guardrails, but again, do it in a way that helps keep the developers productive and allows them to keep working within their standard environment, right? Now, the enforcement piece you see is being done by something we call the deployment firewall. The deployment firewall is a feature of the Delivery Shield product. And just think of this as a rules engine. We're taking some set of standards and requirements and rule sets that you've defined for security, for application releases, and at any time a deployment action is taking place, this could be a deployment to testing, a deployment to staging, a deployment to production, we're going to evaluate those policies and make a decision as to whether or not that release should go forward. And that's what you'll see here in the demo.
I've got a Git repo here where I've got, as David had mentioned, good code and bad code. And I've also got my Jenkins system, which we'll watch as I submit my PR. And this is ultimately going to get deployed through Argo or attempted to be deployed through Argo. Now, a couple of things just to help you understand. Right now, the current deployed active artifact is 225, version 225. And if I go here just to prove that out, you can see here that my images are 225, right? So that's currently what I have in place right now. Now, what I'm going to do, and as we'll go through here and see, I can also see the block deployments, right? So we'll use this to prove out the fact that the deployment was actually blocked. So now I'm going to come back here and I'm going to submit my pull request. So I'm going to go through the process of saying I want to deploy to prod. and I want to merge from the critical branch. And that just means that this is my critical code. So I can create this pull request, demo 3, and I can go ahead and actually create it. So that'll go ahead and actually, now that once that pull request goes through, it'll go through and start the process of creating my build in Jenkins. And you can see here, just for the purposes of the demo here, we want to keep an eye out for build 226. That's the build that we're going to follow through the process. Now, again, I've merged from the critical branch. That means there's a critical vulnerability in here, and there's a policy that I've put in place to mark critical vulnerabilities as a deployment blocking event. So I want to make sure that we stay keen to that fact. And so as soon as this finishes, and it will go through, and we'll take a quick look at it, and then we'll give Argo an opportunity to then identify the fact that this new artifact is shown up in an artifact repo. And if we look here, you can see that this has been built, build 226. Now I can come back here, and by the way, what we'll be looking for in here is the disposition of build 226. Whether, as you can see, 224 was blocked, 225 is what's currently controlling. So if we come back to Docker and to Argo, and we synchronize, what we should start to see here is the various jobs kicking off to ultimately go down the path of trying to deploy 225 to this system. And again, we'll look here and look at the details. But I think, at the end of the day, that's ultimately what we're trying to do here. And you can see here, 225 is what it's, attempting to deploy. And so we'll give it an opportunity to go through its process and attempt to do that. And we'll also keep an eye on, our replica sets as well as we go down that path. And we'll just give this a few minutes to attempt to go through and do that. And again, I think, the idea behind this, while we're waiting for that to sort of work its way through the process, guys, is, again, this is another area where, again, I can effectively use a tool like this to add those guardrails or add effectively a circuit breaker as I've come up with scenarios that I just don't want to see in production. And so that's really what our customers are looking at, is they're saying, all right, there are certain scenarios that I want to make sure never show up in production. And, I've got this automated process, which is great. But again, I want to make sure I've got those guardrails there. And so we're going to continue to sort of, provide that circuit breaker. And by the way, guys, you can see here, if I were to look, build 226 attempted to deploy, and it was blocked, right? So this was denied based on violations of the SSD deployment firewall policies. So this is Argo attempting to go ahead and do that deployment, right? If we come back to the product, we can see 226 under block deployments, right? And then if we click on a section here to understand why it was blocked, we very quickly are able to get to the policy that blocked it, right? So this is the critical vulnerability policy. This critical vulnerability was found in an artifact that we were attempting to deploy, and we had marked this policy as block, right? So, and by the way, this is not required, guys, right? Like, if you were to mark this policy as alert, we would have gone through with the deployment, and ultimately, it would have deployed as usual, only it would have triggered an alert instead of blocking the deployment. But at the end of the day, you can see here, that the emission controller at work, and then obviously us reporting that back through the tool, which would also then generate an alert out to various stakeholders, the developer, who would probably already know because they're monitoring the Argo logs, or they're monitoring the Spinnaker logs, or whatever it is they happen to be deploying through. They would get this message back through that logging. So hopefully that's helpful.